Okay, we'll walk through the solution to Mechanics and Materials Quiz 2 for Spring 2019 at Dunwoody College of Technology. We're given an assembly here with two cords. We have cable or wire AC over here on the right side and AB on the left side. Both of these wires have a diameter of 3/8 of an inch, and we have the material A992 steel. We're told this yield strength is 36 KSI, and we're to use a factor of safety of 1.8 on that yield strength. So I also have the way that you earn points listed here. You earn 2 points for calculating the correct allowable stress value. You get a point for each equation of equilibrium that you need. We'll solve for the forces or tensions in each wire in terms of P, so there's some points for partial work there. And then finally, the correct value of P max with units is worth 2 points. So starting, we'll outline our approach here. Step 1, we're going to calculate our allowable stress. Step 2, we'll draw a free body diagram and develop equations of equilibrium. Step 3, we'll solve for tensions AB and tension AC in terms of P. And then finally, solve for P using our allowable stress. Alright, so that's our approach. We'll start with sigma allowable. If you recall from the section, we had sigma allowable as our sigma at failure over our factor of safety. So that is going to be our 36 KSI divided by 1.8. So that will get us 20 KSI. Alright, so we've got that section done. Next, we'll do a free body diagram. I'll just draw my little free body diagram over here. So we're going to have tension here. This is AB. Depending on how we define this, there's 45 degrees here. Here's AC. This is a 345. This isn't giving us much more than our original diagram here in this case. There's P. I'm going to also define a coordinate system. So I'm going to have X, Y for solving my equations of equilibrium. So I've got the free body diagram done. Now the equations of equilibrium. Do some of the forces in X first. They have to add up to 0 to be in equilibrium. So we're going to have TAB, and as I've drawn it here with that 45 up there, I'm going to have sine of 45 to get me this component going this direction. And that's going to be negative direction since X is positive to the right. Then I'm going to have plus 3/5 AC. In the Y direction, both of these are pulling up, so I'm going to have TAB, and as I've drawn my angle, I have cosine of 45 degrees plus 4/5 TAC. And I didn't do a good job drawing this to scale. It should be more up than to the right. But there's my equations of equilibrium, so I've got that part done. So now if I look at that, oh, sorry, I skipped the load. We're going to subtract P from that because P is acting down. So that adds up to 0. So now I can solve one in terms of the other and substitute that in for P and find values of each tension in terms of P. So if I do that using some of the forces in X, if I rearrange this, pull that down here, so I'm going to have TAB sine 45 equals 3/5 TAC. So I'm just going to divide both sides by sine of 45. We get TAC times 3/5. I got it a little messy. Divided by sine of 45. and in the y direction, subbing that into here. So we're going to have P equals TAB cosine 45 plus 4/5 TAC. And if I substitute this here in for TAB, my sine of 45 and cosine of 45, since it's 45, will cancel out. So I get 3/5 TAC, excuse me, plus 4/5 TAC. So that was a unique situation since these were the same. Sine of 45 and cosine of 45 are the same in that case. So if I rearrange this, P is 7/5 TAC, or TAC equals 5/7 P. Putting that back in, TAB, so I have 5/7 P in here, multiplying that through, I get 0.60609 P for TAB. Alright, so we've got our tensions in terms of P. So we've got step 3 done. Now we're going to find P using our allowable stress. So we know that sigma allowable is going to be equal to our tension, or force, over our area. So we're going to have 20 KSI equals, and which one of these is going to drive? Well, 5/7 equals 0.714143 P. This one's 0.6069 P. Each area, I'll maybe calculate area here, is going to be pi over 4 times d squared. D up at the top was 3/8 of an inch. So we had 3/8 of an inch for both wires. If these are separate wires, we'd have to calculate those areas. If they're different diameters, we have to calculate them separately and fill them into the correct equation here for the allowable and that tension in the wire. So that's going to be pi over 4 times 3/8 squared, and it gets you about 110 inches squared. So which one of these is bigger? This one is the bigger P, so that should be our limiting case. I'll do both of them here. 7143 P is our tension over our area, 0.110 inches squared. So I get 2.2 on this side divided by 0.743. So P equals 3,092.4 pounds, or it goes to 3.1 kip. If I'm going to, let me call it 309 to 3 significant figures. For the other case, this is for AC driving. For AB driving, it's the same setup. I'm going to have 20 equals 0.60609 P over 0.110 inches squared. Multiplying that across, P equals 3.644 kip. Which one do we select? We select the smaller one, otherwise we'll be overloading AC when we put this 3.6 kip load on. So the correct value for P max, 3.09 kip. So to review our steps, step 1, we calculated the allowable stress, and then we needed that at the end. I could have done it at the end. I wanted it at the beginning just to practice our factor of safety and think through that process. Step 2, we drew a free body diagram and set up some equations of equilibrium to solve for our tensions in terms of our applied load. And that's what we did in step 3, is working with those equations to find our tensions in terms of P. And finally, in step 4, we solved for P using that allowable stress. And we had two different values, and we ended up selecting the lower value to avoid overloading the higher percentage cable that took more of the load. And as you might suspect, since they're the same diameter, the one that is more vertical will give us the more limiting case. So in this case, 4/5 compared to, so that 0.8 compared to 0.7 or so for the sine of 45 or cosine of 45 here. So I hope that was helpful in clearing up any points that were not clear at the conclusion of the quiz.